You? Yeah. Go. You go. You can start the talk. Thank you.
Okay. Thanks. Yeah, welcome everyone to my talk, Hibernate in Complex Projects. Speed it up a little bit, please. So in the next 42, I don't know how many minutes, depending on how many questions we have, we will talk about common Hibernate performance issues in complex projects, most of them related to performance. Let me quickly introduce myself before we start and tell you why I'm here talking about Hibernate. But I've been specializing in JPA and Hibernate for the last, well, really specializing for probably about 10 years, working with it about 20 years. I'm also an organizer of the Java user group in Paderborn. And yeah, it's my pleasure to be in Bordeaux this evening and to talk about Hibernate. I have the chat opened on the left. If you have any questions, feel free to post your questions at any time. I will keep an eye on the chat and do my best to answer the questions immediately. And just in case I miss a question, then please repeat them at the end of the talk, and then I'll do my best to answer it. Okay, let's start. When we are using Hibernate in complex enterprise projects, then the mapping itself quite often isn't the biggest issue. The issue that we there have usually is performance, like in most other projects as well. Implementing a basic persistence layer that just maps some database tables to Java objects is pretty simple with JPA and Hibernate. Doing it in a way that performs well under high load with lots of parallel requests and users and everything, that's a totally different topic. So in tonight's talk, I will dive into a few common pitfalls that you should avoid when you're using Hibernate in complex projects. And I will, of course, show you how you can find at least most of these issues before you deploy them to production, so that you have a chance to adapt your code before you're running into real issues with it. Yeah, when we are talking about performance, we are usually talking about two things. First of all, how do we find these issues? And then how do we fix them? So let's start with finding them. And there we quite often have the complaints that Hibernate would be a black box, that it does just some crazy statements and nobody knows what Hibernate is doing internally. And I want to show you that this is not true. Hibernate is pretty predictable in what it does, as all frameworks. And you can let Hibernate tell you about the things that it does. And that gives you all the information you need to improve the performance, or to make sure from the beginning that the performance of your application is right. So the component that I want to show you there is the Hibernate Statistics component. That's part of the Hibernate core component. And the main benefit of this component is that it can track and tell you about all the things that Hibernate does internally, because who better to ask about what is going on internally than Hibernate itself, right? So to activate these statistics, you need to set the Hibernate.generate statistics configuration parameter to true. You can do that in the persistence.xml file or in a system property. I always recommend doing that in a system property, because you don't want to activate this parameter in production. It's great for development, but collecting all this information slows down your application, and you really don't want to do that in production. So better make sure that you set the system property Hibernate.generate statistics on your development system, and then you're not at risk of shipping it to production. The next thing you should do is you should configure your logging in the right way, so that you actually get all the information that the statistics component can provide you. And to get all this information, you should set the org.hibernate.stat logging category to debug. So let's get into the IDE and take a look at all of that. So what did I do? I set the org Hibernate stat log category to debug as explained before. And in my persistence.xml file, I set the Hibernate.generate statistics parameter to true. As I said earlier, in a real project, I would recommend doing that as a system property. But here it's an easy way to activate the statistics and to be sure that they are always active, even if you just check out the project from my GitHub repository and then download it. I will share the link to the GitHub repository and to the slides later at the end of the talk and on Twitter. Okay, so we did this. So we set up our project, and now let's run this test case and see what happens. The test case itself looks pretty basic, right? I mean, I just select all the authors in my database, and then I write a simple log message in which I print out the name of the author and the number of books that author has written. Shouldn't be a big deal. Well, if we look at the log output, then we see down here that we have a bunch of session metrics at the end. That is a summary that we get when we activate the statistics. We always get that at the end of each Hibernate session, and it aggregates all the important information that we need, like this part here, which tells us how long Hibernate took to execute 12 JDBC statements. There we have an interesting detail. 12 JDBC statements, but we only have one statement up here. So that is something that we should check in a minute. But before we get to that, I want to show you a few other things you can find here in the statistics, and that is the second level cache interaction. I don't have any here because I haven't activated it in this simple example. The number of JDBC batches that were executed, where we only had a read operation. JDBC batches are used for write operations, so no batches for this run. And then, of course, the flush operations that happened, how long that took, how many entities were involved, and so on. So let's get back to the 12 JDBC statements, shall we? Here, we saw how long it took, a bunch of nanoseconds, and we saw that Hibernate executed 12 JDBC statements. That's something we should check. If we only have one query up here in our code, we should double check why we're executing 12 statements. Let's see where the test started. Started here, select our authors. Here we see the SQA statement that Hibernate executed for this JPQA query, which is the one that you can see up here. So this line in the log is from Hibernate statistics component. You get that if you set the org Hibernate stat category to debug. And there you see the JPQA statement that we executed, how long the statement took, and how many rows it returned. It returned 11 rows. And to get these 11 rows, we executed one statement, right? That almost already tells us what happened. Hibernate executed another SQA statement for each row returned from that select a from author A query. And these queries, you can see them here. We selected the books for that author, and here we did the same for the next author, and so on. You see always the same query. And the reason for that is this call of the getBooks.size method. By calling the size method on the list of books, we force Hibernate to get all the books from the database so that we can then count it in our Java code. That's, of course, not an ideal approach. There are way better ways to do that, like using a count function in the query statement, but that's another topic, about which we can talk later. Okay, but you see, by activating the statistics, you get all the information that you need to see what was going on. So, how many statements did Hibernate execute? And you saw up here which queries did Hibernate execute. The queries to get the books, the query to get the authors. So there's no reason anymore to complain that Hibernate would be a black box. Okay, based on this information, we can now start looking at typical causes of performance issues. Emil asked to zoom into the log a little bit. Emil, is that better? So here you can see a little. Okay, let me zoom in another step. So here you can see the 12 JDBC statements in the log in the statistics, and here you can see the SQA statement that got the books from the database. So again, we had this one statement up here that got the 11 authors from the database, which was the query that we had here in our code. And then we had another select statement for each of these authors to get the books. And that would have been something that would have been actually pretty hard to spot in our Java code. But it becomes very obvious when we are taking a look at the log output and at the activated statistics. Okay, let's talk about typical causes of performance issues or issues in general with Hibernate in more complex and bigger projects. First of all, there are inefficient mappings. That happens every now and then, and I will show you the most typical example for that in a bit. And then, of course, we have slow select statements. That happens all the time when you are working with the database. Unfortunately, wrong fetch types are still an issue with Hibernate. When you look at Stack Overflow and typical questions that are asked there, you still find a lot of bad advice, unfortunately. Also a lot of good one, sure, but quite often still find recommendations there to use FetchType eager and similar things that cause lots of performance issues when you deploy the code to production. And then we will also take a look at the issues that arise from loading the same data multiple times in your application, either because you modularized your application in a way that you need so that each module needs to request the same information again, or because you're using your application in a multi-user environment and each user needs to fetch the same information again. Yeah, Clement, you're absolutely right. The issue that I just showed you in the IDE was a typical N+1 select issue. We had one query that got n authors from the database, and then we have another query for each of these n authors. So overall, we have n+1 select statements, which is a typical issue arising from wrong fetch types or from the wrong handling of lazily fetched associations. And later on tonight, I will show you a good and easy way to avoid all of that. Okay, let's go and take a look at inefficient mappings. The most common inefficient mapping that I find in all the code reviews and coaching projects that I do are lists that are used to model a many-to-many association. I mean, from a plain Java point of view, using a list to store a collection of other entities, like all the books written by an author is a pretty obvious thing. I mean, list is an efficient and very common data type. Unfortunately, with Hibernate, it isn't that efficient, or at least not as efficient as you would expect. And we will take a look at that right now. So let me switch real quick to the mapping pitfalls. So here we have a book entity with a typical many-to-many association and a list of authors. And if we take a look at the authors, here we have as a bidirectional association, basically the same. So just a list of books annotated with many-to-many, something that you find in lots of projects. So from a Java point of view, that might look great. But as I will show you here, from a Hibernate point of view, that's not ideal. So what do I do here in the test? I get a book by its ID from the database. And then I get one of the authors from the book and remove it from the list of authors. So what would we expect here? We would probably expect that Hibernate takes the ID of the book and the ID of the author and removes the according record from the association table between the book and the author, right? I mean, it's a basic many-to-many association. And we said here that we want to have a join table called book author. And that one has the ID of the book and the ID of the author as foreign keys. And that models the association. So if we remove an author from the list of authors of a book, Hibernate should just remove that record. Let's take a look at the log output. Here we see that Hibernate removed all records for that book from the book author table. So now we have no authors left for that book. We removed all of them. And then Hibernate iterates through the list of remaining authors and adds each and every one of them, which isn't a big deal in this example because that book was only written by 2 authors. So instead of removing just one author from that, or one link from that book author table, we are now removing all of them and adding another one. But let's say we have a book that was written by 10 authors and we remove one of them. Then we suddenly have 1 delete and 9 insert statements. And that not only looks pretty weird in audit logs and in our SQL log here, it also creates pretty nasty performance issues. So how can you avoid that? There's a really simple way to avoid that. You switch your list to a set. Then I need to change the getters and setters down here as well, of course. So what we're doing here is we are replacing a list that doesn't put any constraints on equality checks and on duplicates and so on with a set where we make sure from a data point of view, from data type point of view, that there are no duplicates in it. So Hibernate can specifically identify the record that needs to be removed from the association table. And based on that, Hibernate then just executes one SQL delete statement to remove one record from the book author table. And that is the one that we just removed from the list of authors of that book. We simply just removed the book ID and the author ID, the record with the book ID and author ID that we provided. Then there's another pitfall when you are working with associations. As you just saw, I modeled let's go up here. I modeled the association between the book and the author as a bidirectional one. So you can navigate it from the book to all authors and back. So from the author to all of their books. If you do that, then you need to be really careful on how you manage the association between the author and the book. Let's say I want to add a new book, and that was written by the author with ID 1. So a thing that you see quite often in the code then is someone gets the author and the list of books of that author and just adds the new book to it. And I mean, that looks pretty fine here. Right? I mean, if you don't check the book entity, that is totally reasonable code. But if you now take a look at the log output, you see that for this test case, we select the author. Sure, that's the one that we wanted to, for which we wanted to add the book. Then we insert a record into the book table. Also pretty expected. I mean, we persisted a new book. And then we have a select statement that is triggered by the here down at the end of the test case to validate some of the input that we did. But what we didn't see was the insert statement that adds a record to the book author table. Right? That's a select statement. That's an insert into the book. That's a select statement. We didn't persist the association between the author and the book. That means if we are now selecting the book from the database, there is no author for that book. But we set it here. Why didn't Hibernate persist that? The reason is simple. Because we only added the association on the referencing side of the association. So we took the authors and added the book to the list of books for that author. But because it's not the owning side, Hibernate doesn't persist the change. Okay, so let's change that. Let's add the author to the book. If we now run the same test case, then we can see here that we now inserted the record into the book author table. So much better than before, right? Well, it's better, it's still not great. So we had an author here, the author with ID 1. And to that author, we added the, we didn't add the book, we just added the author to the list of authors of that new book. So if we now in our code get the author and print that one out, then we have here just the author with first name and last name. Right. Let's do a quick debug run here. So here's the author. And we don't have the new, it's hard to see now. How do you show you that? The issue now is that, yeah, we added a book with ID 100. But if we take a look at the debugger, we see that we have a book with ID 1 and 2 in that list. So we open up the author with the list of books. And we open up that one, ID 1, ID. Interesting. What did I mess up? We shouldn't see the author in the list of books here. The book in the list of. Let's get to that bit later. Yeah, I need to think about that. I wanted to show you some another issue here with the bidirectional association. For some reason, I messed up my example. So let's stick to that, to what we saw so far. So what we did was we persisted a new book. And as long as we just added it to the list of books for that author, which is the referencing side, we didn't saw that entity. No, we didn't saw the insert statement for the association table in our log output. That only happened after we added the author to the list of authors on the book. And now we yeah, no. I thought I had some inspiration there. To avoid all of these issues, what you should actually do would be to implement this method here, like add book, remove book, where you add a book to the list of books for a specific author and do the reverse update as well, where you add the author to the list of authors of that specific book to make sure that author and book also in your current persistence context are up to date and don't get outdated. Yeah. Let's go to the next topic, slow select statements. That is something that happens really often, or let's say basically in all applications that work with relational databases. It's not a JPA or Hibernate related problem. I mean, that's the reason why we get so many tools for relational databases that help us to analyze the current statistics and execution plans and performance of database queries. And all of these are still part of our tool set when we are working with Hibernate and relational databases. And we should use them to analyze why certain queries with Hibernate are slow. The issue then is, after we analyze the statement, or maybe had a DBA take a look at the database and the query and make performance optimizations to that query, we quite often end up with an SQL select statement that looks pretty different to the statement that we executed in the beginning. And that's not because Hibernate generates bad statements. No, these statements are totally fine. It's usually because we are using database-specific features or SQL features that are just not supported in general by JPQL. So what you can then do is use native SQL statements, and that is something that we will take a look at in a second. The main benefit of these statements is that you can use all features supported by your database, not just the small feature set supported by JPQL. So if you look at the features supported by a relational database from a query point of view, you usually get a pretty huge feature set. You then look at the feature set standardized in SQL, it's much less. And then if you look at what's supported by JPQL or the criteria API, it's even less. So that's the reason why you quite often end up with queries that are just not supported by JPA and Hibernate and all other JPA implementation. And it was never intended by the Hibernate team or by the JPA expert group to create a query that sits on top of SQL that supports at least the same feature set. That wouldn't make a lot of sense. I mean, that query will never be better than SQL because SQL is the only thing that the database understands. So what they did there is they defined JPQL as a query that supports a feature set that's good enough for all basic standard use cases. And then they introduced the native query capabilities that give you direct access to the database via native SQL statements. And these statements are taken by Hibernate and sent directly to the database. That has, as I said, that has the benefit that you can use all the features supported by a database, but you're also writing SQL statements in the database-specific dialect. That's something you always have to keep in mind, especially if you're working with multiple databases. Another issue is that native queries return object arrays in general. And I have a few examples prepared that show you how to map these object arrays to something you actually want to work with. So let's say we have a query that shall return author entities. So we are selecting all the columns mapped by the author table. And let's say we want to do a native query because we have some very complex or very efficient proprietary feature we want to use from the database. Then we can select just all columns and provide the class, the entity class to which we want to map the result as the second parameter. When we do that, then Hibernate applies the same result mapping that it does for the entity manager find method or for JPQA queries that return entities to the result of the native query. So Hibernate takes our native query statement that we had in the code, just sends it to the database, gets back a result set, and then iterates through it and applies the information from the entity mapping to the result set, which means Hibernate instantiates a new author entity and then uses reflection to set first name, last name, ID, and version. Well, that works fine for all the queries that return all columns mapped by an entity and for result sets in which the column names in the result set are the same as you have in your entity mapping. Quite often, we have more complex queries and result sets. We have queries that return entities and scalar values, like this one here, where we have a query that selects all columns mapped by the author entity, and we count the number of books written by that author. Might be pretty useful for some custom validations in your business code, for lists in your front end where you just list the authors with the number of written books, or similar use cases. So what shall we do there? Well, if we don't do anything, then Hibernate returns an object array with 1, 2, 3, 4, 5 fields, and there are no additional information about that. Not about the type, not about the content itself. You need to remember that in position 3, there's a string with first name, and in position 4, there's also a string, but it's last name. Can't easily use that for updates. That's not a pretty comfortable projection. What you can do is you can reference an SQL result set mapping by its name as the second parameter. In this case, I called it author book count. So let's take a look at the author where I defined that mapping. You can see it here. Annotation, SQL result set mapping. Name is author book count. That's the same string that I had as the second parameter of that query. And I defined that I want to get back entities. First of all, the author entity and a long. And if I run that test case and execute the query, then I get back an object array. But this object array is a special one. Usually you would get an object array that has, as I said before, one field for each column selected up here. Now we get an object array with 2 elements with the author in position 1 or 0 for 0-based access, and then in the second position, the number of books. And you see that here, the author, Joshua Bloch, wrote 1 book, at least based on the information in my small test database here. The interesting thing is that the author entity, which we now have in position 0 in that array, is a managed author entity. That means you can do all things with it that you usually do with an author entity that you would get back from the entity manager find method or from a JPQA query. It means you can simply call the remove method on the entity manager to delete that entity. You can call setter methods on it to change attributes and let Hibernate update the database record. Or you can traverse associations from the author to all books, for example. That entity just behaves as in the same way as any other entity in your application. Right now we saw two mappings. There's a third one that I want to show you. In the two previous ones, we used entity classes to map our result. That is good for write operations, but entity objects come with an overhead. I mean, Hibernate has to check if we changed something, and it does that based on the entity lifecycle and based on the entity lifecycle state managed, where the entity is part of the current persistence context, and Hibernate basically has two copies of it. And whenever it flushes, the persistence context gets all the entities and takes the copy of that entity object that we got and the copy of that same entity or database record that Hibernate kept to itself, compares all attributes, and as soon as there's one difference, Hibernate generates an update statement. It's pretty obvious that this creates an overhead, right? I mean, with Hibernate 5.3, I did some tests, and at least on my machine and in my test setup, I had a difference of about 20% while selecting the same information with a DTO and an entity. So that shows selecting DTOs is the way better approach for read-only operations, where you don't benefit from all the dirty checking and generation of SQL update statements and so on. And next benefit is you can design your DTO class in a use case specific way so that it contains only the information that you need. So let's say for some part in the front end, we need the name of the publisher and the title of the book. We could create a book publisher value class for that. And that one just stores these two attributes. We create a constructor that expects these two values as parameters. And then we have here the typical getter and setter methods, which gives us a pretty efficient and easy to use data structure. The question is, what do we do with our query? How do we get these two fields into the book publisher value object? Well, we can, of course, just execute the query, iterate over the list of object arrays that we usually get from a native query, and call the constructor ourselves. But there's an easier way to do that. We can define an SQL result set mapping. This case, I called it book publisher, and use a constructor result annotation to tell Hibernate that we would like to instantiate a book publisher value object, and that the title column of the result set shall be provided as the first parameter to the constructor, and the name as the second parameter. So we are calling this constructor here, putting the title as the first and the publisher as the second. And if we now run the test case, then we see that Hibernate returns us a list of book publisher value objects, and that we have the information here, and that effective Java was published by Addison Wesley. So what does Hibernate here internally? Hibernate executes this native SQL statement, gets the result set from the database, and then uses the information that we have here to instantiate book publisher value objects with the constructor that takes these two parameters via reflection. That's basically the same as Hibernate does in a JPQL query, in which you use a constructor expression. Here you can do the same with a native SQL query. Okay, so much about native queries and result set mappings for now. If you have any questions about that, please post them in chat, and then we can dive into the details there as well. Okay, then. Yeah, Clement, you're right. Clement just wrote in the chat that because of a native query, we can't call the select new expression that we would do in JPQL. So what we would do in JPQL is we would do an em.get create query, select new, then we need the name of the package, dot publisher value, b.title, p.name, from book, b join b.publisher p. B.id equals 1. So this is what we would do in a JPQA query. There we can call a constructor using a so-called constructor expression in our JPQA statement. And well, we can't do that with native queries, because native queries, because JPQA queries are passed by Hibernate. So Hibernate, when we execute this query here, let's actually execute the query. So we get a single result, and this is B. Okay. Let me zoom out a little bit so that I see what I'm doing here. Okay, so what Hibernate does with a JPQA query, if we write this here, then Hibernate parses the JPQA statement and recognizes, okay, we have the keyword new, so we know this is a constructed definition. That's not relevant for the SQA statement that we need to generate. The relevant part is this, title of the book and name of the publisher. And that is what Hibernate does in the select statement. Hibernate then selects the title of the book and the name of the publisher in the SQA statement. And this information here is kept for later. It's kept until Hibernate receives the result set for this SQA statement. And then Hibernate uses the information provided in this constructor expression to instantiate book publisher value objects via reflection. Using native queries, we can't do that because Hibernate just takes this SQA statement and sends it to the database. So we need to provide reference to the book publisher value mapping, SQL result set mapping, and we define that here. And then Hibernate has all the information it needs to instantiate the book publisher value object. So to call a constructor with these parameters. Okay, let's take a look at association fetching. This is something that is affecting one of the key components and key parts of JPA. Mapping associations between database tables, and by that also between our entity classes, is one of the key features of JPA. The automatic handling of these associations hides a lot of complexity from us as a Java developer. At the same time, it introduces a high risk to mess things up and to actually break something performance-wise. So let's talk about the fetch type first. That's probably known by most people already. But let me repeat that real quick. So the fetch type defines when an association between two entities is fetched, so between the author and the book. And it's a static definition in our entity mapping. That means there's exactly one definition for an association between two entity classes. So we can either choose between lazy or eager, and that will be used everywhere. And that makes the static definition of the fetch type so problematic, because you will not find one static fetch type definition that is the best fit for all of your use cases. You can choose between lazy and eager, as I said before. Lazy tells Hibernate to fetch the association when you access it for the first time. That's the default for too many associations. And that one is great to avoid any overhead. Eager, on the other hand, loads the association immediately when you get the entity from the database. And that's the default for to-one associations. And that can be good if you're fetching the association within the same query. Unfortunately, with fetch type eager, Hibernate doesn't do that in most cases. It does that only when you're loading an entity via entity manager find, but not when you're doing that via a query. Eager usually triggers additional queries, and it does that all the time. So all the time when you're loading these entities, even if you're not using the association in your business code, which is pretty unfortunate. So my recommendation is to use lazy fetching for all too many association because it's the default there and it's the most efficient approach. I will show you in a few seconds after I answered Clement's question from the chat how to handle the situation that you have a lazy association of which you know that you will need it within your business code. That is then the next topic we will be talking about. For to-one relationships, there I also recommend to use fetch type lazy for all associations that you create new. So if you're introducing a new to-one association into your domain model, please make sure to set the fetch type to lazy. But I know that in most projects out there, the association are fetched using their default fetch type. And that for to-one associations, unfortunately, is fetch type eager. My recommendation there is, if you have performance problems, take a closer look at the fetching behavior of your entity association there and change it to lazy if you see that the additional queries cause performance issues. But please don't go to your existing code base and decide, okay, from today on, we change all the to-one associations to fetch type lazy. Yes, that is the better approach. I totally agree with that. But doing that refactoring will cause lots of work for you and your team, and it will take quite a while without providing huge performance benefits for quite a lot of your use cases. As long as you're not working on larger lists of entities that have to-one associations, the fetching of one additional entity, which means of one additional record from the database, usually doesn't have a huge performance impact. And I therefore recommend to check the existing to-one associations on an individual basis if that's a if you're finding use cases in which these additional queries slow down your application. By all means, refactor it. It's the right approach. But you will find quite a lot of to-one associations where the eager fetching of them isn't the best solution, but isn't a deal breaker for your current application. Okay, let's take a quick look at Clement's question in the chat. It's about the SQL reside set mapping. And he asked, does Hibernate use reflection as well to build the object? What is the best approach regarding performance issue? So what Hibernate does is Hibernate always uses reflection to instantiate the book publisher value. Hibernate uses reflection to call the constructor with these parameters. So it does that here, and it does that in this mapping for the book publisher value class, and then it looks for a constructor with these two columns. So yes, Hibernate always uses reflection to build these objects. Hibernate, depending on where you put your mapping annotations, like if you do put them on the entity attributes instead of the methods, then Hibernate uses reflection here as well. It then uses reflection to set the ID, version, and first name attribute of the entity class. With the current JDKs and all the optimizations that have been going on over the last several years, using a reflection in these places usually isn't causing any severe performance issues. Performance of that is totally fine usually. There's one thing that you should pay attention to, and that is the constructor of your DTO class. Every now and then I see projects where we are storing JSON or XML documents in the database, or a proprietary blob, so a huge byte array. And then I see DTO classes where these information are provided to the constructor, and then the constructor starts parsing that data, like parsing the XML or JSON document and doing post-processing and doing really expensive operations there. In these cases, the constructor call will become a performance issue, just because of the amount of work that's done there, but not because of the using reflection. Okay, so I said before that you should use FetchType lazy for basically all of your association. The only limitation there was that for existing to-one associations, you should probably think twice if you need to refactor it or not, and avoid any unnecessary work there. Because as always, we can spend ages on performance optimization if we don't limit it to the parts of our application that are actually benefiting from it from a user point of view. When we are using FetchType lazy, we will run into another issue, and that is the n+1 select issue. And we saw that at the beginning of today's session when I had basically the same code that you can see here down on the slide, where we got a list of authors and then called the getBooks method to get all the books, and did something on the book on that list, in this case called the size method. So this forces Hibernate to initialize the lazily fetched books association, which means Hibernate needs to trigger a query. And it does that for each author. And that is often the reason why we see applications that execute thousands of queries for just one use case. So there are 2 to 3 approaches to avoid that. We have fetch joins or join fetch clauses in our JPQL or criteria query. We'll take a look at that first. And then we have named entity graph and entity graph, which are features introduced in JPA 2.1. So, well, now already quite a while ago, that enable us to define a query-independent graph that describes which entities and associations shall be fetched from the database. Let's take a look at that. So we use a write message log method here, and as you can see, that creates a stream based on the list of books of an author and just joins them into a comma-separated list of book titles. So that forces Hibernate to initialize the list of books. And if we just select all authors from the database and then use them to call the method, then we can see in the log output that Hibernate executes 12 JDBC statements. And the reason for that is here, the additional query to initialize the books association. That is the n+1 issue we just talked about. So how do we avoid that? One way to avoid it is to use a join fetch clause in the from part of our query. So here I'm telling Hibernate, okay, please select all authors from the database. And by using join fetch, I tell Hibernate to also initialize the list of books. We will take a look at that in a second. But before we do that, I want to point out two things. First of all, the distinct here. So unfortunately, with the join fetch clause, Hibernate doesn't hide the fact that in the SQL result set, we have each author as many times as they have written books. I mean, that's just how SQL works. If an author has written 2 books and we join, and if you select all columns from the author and the books table and join the 2 tables in the from clause, we get author with book 1 and author with book 2. Then Hibernate maps that to objects and everything, but unfortunately, it doesn't hide the fact that we got that author 2 or 3 times. You can avoid that by adding the distinct keyword to your JPQL statement. Unfortunately, by default, Hibernate adds the distinct keyword to the generated SQL statement, which would be totally fine if we would want to send the distinct keyword to the database, but it doesn't have any effect in the SQL statement. We only need it for our entity object mapping. And for these cases, we have the query hint pass distinct through. And that tells Hibernate, okay, this distinct here is just meant to be used in our Java application and shall not be sent to the database. Okay, so let's take a look. We have this query that selects all authors and join fetches the books. We are down to 1 JDBC statement, which is nice. And then we see here that we have a bunch of authors with the books that they have written. How does Hibernate get all this information? With this query up here. And in that query, Hibernate joins from the author to the book author to the book table, as we would expect, and selects columns from the author and from the book table. So here, our join fetch clause, this one here, not only created a join in the query itself, it also extended the select clause by adding all the books, all the columns mapped by the book entity to the select clause. So we now not only selected authors, we also selected books. As long as you model your too-many associations as a set, you can put multiple join fetch clauses into one query. But please be aware that you are creating a product there. So you're multiplying the author with the number of their books. And if you then join fetch, let's say, the reviews of each book to that, then you multiply that with the number of reviews. So let's say you have an author who has written 5 books, and for each of these 5 books, she got 1,000 reviews. Then we have 5,000 times the author. Each of these 5 books is there 1,000 times, and then we have each of the reviews. And that creates another new performance issue on the database side, because the size of the query is just too big. It can cause network issues depending on the overall load on your network and the number of parallel requests. And it creates quite some load on your Java application, because there we have to pass all that data that we got back from the database. So I don't like to put any hard limits on the number of join fetch clauses, because that would mean that we treat an association that just contains 1 or 2 records in the same way as one where we know that we will have thousands of records, like between the book and the review. And that just doesn't make any sense. So what you have to do there is think about the data structure that you have. Think about the data that you have in a real application, and decide if you will run into performance issues there or not. And, well, if you're not absolutely sure, then just give it a try. Run a few tests. Get a production-like database dump and see how the query performs. You can do, of course, the same with the criteria query. There we have the fetch method on the root interface, and we also have it on the join interfaces. And there you can say, okay, let's create a join fetch clause, and you can then provide the join type. And there you can decide between inner, left, and right join. Something that you can, of course, do up here as well. You could have done left join fetch clause here as well, of course. Okay, that is one way to avoid the n+1 select issue. We saw we dropped down from 12 back to the one statement that we have in our code. That approach is easy to read, but it has the downside that we now create one or require one query for each fetching behavior. So if we want to implement a similar use case that requires the same database query but a different fetching behavior, we would need to rewrite the whole code and have a second database query for that. And with JPA 2.1, we have an alternative to that. We can use an entity graph. So let's take a look at a named entity graph. Oh no, on the author entity. There it is. So with a named entity graph annotation, we can define which attributes we want to fetch with that query. And in this case, I call my graph graph.authorBooks. As with all named things in JPA, this name has to be unique within the current persistence context. And then I define a list of attribute nodes that define which attributes I want Hibernate to fetch eagerly. In this case, that's the books association. And if I do that, then I can get the entity graph by its name from the entity manager and provide it as a hint to my JPQL query, to my criteria query, or to my entity manager find call. And if I now run the test case, you will see that this results in exactly the same behavior as we saw before. So as you can see, we have one JDBC statement again. And up here, we have the same query as we had before. In this case, just with a left outer join. In the example that I created before, we used a simple join. But as I said, you could do the same with a JPQL query as well. Okay, so these are your main options to do that. In addition to the annotation-based approach, you can also use JPA's entity graph API to do exactly the same, just dynamically at runtime using a Java API. In this case, with an entity graph, you can see that here, you don't need to add a distinct keyword. That is something that Hibernate then handles internally for entity graphs, unfortunately not for joint fetch clauses. But you still keep the downside in both cases that this query here joins the author with a book and selects from both database tables. So if an author has written multiple books, you get the author information multiple times, each and every time with a different book. And that quite often results in performance issues if you're join fetching too many associations. Yeah, and Clement just asked about the Cartesian product in the chat. So Clement, I expect you probably ask about the missing distinct I just talked about here, right? Yeah, okay, exactly. So yeah, for the, where's my joint fetch clause? Here. For the joint fetch, we need the distinct keyword here. And for an entity graph, we don't need it. I would prefer it if it would be the same in both cases. And if Hibernate would hide that product for a joint fetch clause as well, because from my point of view, that's the only reasonable approach. Because if you remove the distinct keyword here, you will get multiple references to the same, exactly the same author entity object within that list. So then Hibernate adds the exact same object, not only an equal object, it's the same object in memory. Hibernate adds that multiple times to that list. And yeah, from my point of view, that just doesn't make a lot of sense, but that's how it's implemented right now. Maybe we get an improvement on that in the future. I hope so, but yeah, I'm not sure. Okay, so we had a quick look at a few mapping pitfalls. We had a look at the fetching of associations and said we would like to we would like to fetch associations lazy each and everywhere and only add query-specific fetching when we need the association in our use case. That already solves a lot of performance issues. Let's now talk about caching. Caching helps us in all cases in which we read data multiple times. And well, if you're working with Hibernate, or if you speak with someone who works with Hibernate and ask them how Hibernate interacts with the database, most developers think of something like this. So we have a Hibernate session in the database, well, and then there are some SQL statements and result settings going back and forth between them, right? Well, that's not wrong, but it's also not right. As so often, it's a little more complex. So first of all, we have a first-level cache. The first-level cache contains references to all entities that were used within the current Hibernate session. The first-level cache is also called the persistence context. So there we have copies of all managed entities that we have used so far. And whenever we read an entity from the database that we had read before, so let's say at the beginning of our transaction, we load the author entity with ID 1. And sometime later, we execute another query that also returns the author entity with ID 1. Then Hibernate will recognize that and ignore that record in the result set of the second query and get the author entity object with ID 1 from the first-level cache instead. So Hibernate there ensures that there's only one object that represents a specific database record within each Hibernate session. The first-level cache also contains dirty entities. Because if you load an entity from the database, Hibernate adds it to the first-level cache. Then you call setter methods on this entity object, and Hibernate keeps that object in the cache or in the current persistence context until the end of the session. Now, the interesting question always is, when does Hibernate write these changes to the database? And the correct answer to that is, that depends. It depends on when Hibernate flushes the persistence context, and that can be before any kind of query that Hibernate executes, because the database obviously has to have all the information to answer a query correctly, or Hibernate also flushes all changes before the commit, because, well, we need to send all the changes to the database before we commit the transaction if we want to make sure that all changes are stored permanently in the database. So Julian asked, how big can this first-level cache become? Basically, as big as you have memory available. There is no limit. And that can be an issue for batch jobs. It was a batch, so for batch imports or updates, like these typical nightly runs where you get 2 GB of XML file and you just import it into the database. With older Hibernate version, the first-level cache, there quite often cause performance issues because, well, Hibernate has to manage it. It consumes memory in your JVM that isn't available for other operations and all these kind of things. With Hibernate 5.3, the team did a lot of work on the internal handling of all these things, and the first-level cache is now way more efficient than it was before, and it usually easily handles several thousand entities. if you have a reasonably sized memory configuration for your application. But yes, you might every now and then need to clear any other operations. In addition to the first level cache, we can have even more caches. Then there's also the second level cache. As you can see, that one is now independent of the Hibernate session. So while the first level cache is part of the Hibernate session and contains dirty entities, the second level cache is separate of that. And that means that you can gain performance benefits over multiple calls to your backend, which means over multiple Hibernate sessions. The first Hibernate session reads a record from the database, then stores an entity object for it in the first level cache. And when then later on another session tries to access the same database record, Hibernate then can get it from the second level cache. The important thing there is the second level cache is only used for entity classes, and it's not used when you execute a query, so not for JPQL, native, or criteria queries. Hibernate only accesses the second level cache if you call the entity manager find method or traverse an association, but more about that later. And then we have the query cache. That is the only Hibernate-specific cache. The query cache stores query results. And Julian, I just saw that you said there was a bit of a freeze at the end of my answer. Shall I repeat a part of it? So I basically said that for huge batch jobs, you might need to flush and clear your persistence context to clean it up. But that is something that you should first analyze using a performance test for your batch job and see if the throughput of your batch operations drops over time. If it does, then calling a flush and a clear quite often solves that issue. If it's caused by Hibernate. For all regular use cases, please don't flush or clear your persistence context. It doesn't provide any performance optimizations there. Hibernate handles that way better than we could do that. I mean, that are the benefits of a library that has been used for about 20 years in millions of projects. Yeah, trying to optimize there something with flush or clear usually just messes up Hibernate's optimizations and performs worse. Yeah, what did I talk about before that? The query cache. The query cache is Hibernate specific, and it contains query results. That's the only cache that contains query results. The problem there is that the query cache gets invalidated quite often. Hibernate has to invalidate the query cache for all query results that affect a specific database table as soon as you perform any write operation on that table. And due to that, there are just very few database tables and queries for which caching the result actually makes any sense. The second level cache is a little bit better in that regard because there Hibernate knows which objects were changed and can then just invalidate these specific objects instead of all authors, for example. Yeah, I already talked a little bit about the first level cache. And yeah, let's summarize that real quick. So the first level cache is activated by default. As you saw, it's linked to the Hibernate session, and it's a key component of JPA and all its implementations, which of course include Hibernate. It contains all the entities that you used within your current session, and Hibernate uses it for its internal optimizations. You can't deactivate it. It's always there, and you don't need to think about it. Then we have the second level cache. The second level cache requires more attention from us. That one is session independent, as you saw in this simplified diagram, and you need to activate it. And there's a good reason for that, and that is that using the second level cache is only useful if you have lots of read, but just a few write operations on that specific entity class. And that is because the second level cache creates an overhead. I mean, Hibernate needs to first check if an object is in the second level cache. And if it's not, then Hibernate is still going to the database. So in these cases, we just were a little bit slower than without the cache. And for all write operations, Hibernate needs to update the record, the object in the second level cache. And that creates an additional overhead that slows down the application. The rule of thumb there is that you need 9 to 10 read operations approximately for each write operation on a specific entity object. So that means if you want to cache author entities, you would need to read on average the author with ID 1 9 to 10 times before you update it or remove it. If that's the case and you activated the second level cache, I'll talk in a second about how you do that, then Hibernate uses the second level cache totally transparently. You don't need to do anything there. Hibernate automatically uses it whenever you call the entity manager find method or when you traverse the association. The cache itself isn't part of Hibernate. That is an external component. Hibernate just defines an interface for the integration with the second level cache and the JPA spec as well. And that means you need to provide an additional library like InfiniSpan, which is the cache implementation from Red Hat. So both are from the same company. EHCache is a popular one. Seen Hazelcast in a few projects. Yeah, there are several cache implementations out there. And as long as they implement the JCache specification, all of them integrate easily, almost out of the box. If they don't implement that, then take a look at the Hibernate documentation. You will most likely find a description on how to integrate with that cache. So to activate the second level cache, you need to set the shared cache mode, first of all. Depending on the shared cache mode, you then might need to do more. And with the shared cache mode, you can choose between 5 different modes. First of all, that would cache all your entity objects. I don't recommend using that because, as I said before, you need 9 to 10 read operations for each write operation on that specific object, and that's just not the case for most of our entities. None, where that's a reasonably default, but we would most likely not use that in our own configuration. And then we have the 2 really useful configuration settings, and that are enable selective and disable selective. Both of them enable you to define on an entity class level which entities shall be cached. I personally prefer enable selective because there we need to do something on the entity class, which means we need to add an annotation to actually activate the caching for it. With disable selective, it's a complete opposite. All entities are cached by default, and you need to add an annotation to avoid the caching. I think enable selective is less error prone. I hopefully think at least for a few seconds before I add the caching annotation to the entity class. And without doing that, the entity will not be cached. So Julian asked if we can define a time to live via those annotations. No, that would be part of your caching configuration. So you would need to take a look at EHCache or InfiniSpan, how they invalidate the objects in the cache. So what you can usually do there is you can define the size of your cache, And then you can define a certain mechanism that is then applied to remove objects from the cache if you reach that threshold. And that can be either a time to live, or what I personally prefer is the least recently used approach, so where we remove the objects from the cache that we haven't used for a while. And that is, depending on the cache configuration, that's combined with the time to live setting as well. Okay, then let's take a look at the second level cache. So what I did here is I have my persistence.xml. I set the shared cache mode to enable selective in the configuration, which means I now need to activate caching for the entity classes that I want to cache. And what I did here, because I'm running in a standalone environment, is I configured the region factory class for cache. If you're using Java or Jakarta EE application server or Spring, you don't need to do that. You get this integration out of the box. That's just required in my specific test setup here. And on the author entity, I added the cacheable annotation. That is the annotation defined by the JPA spec. You can see here it's part of the JavaX persistence package. So that is the standard annotation. Hibernate has its own annotation. It's called cache. And there you can set the concurrency strategy on an entity level. Gives you a little bit more flexibility. In most cases, setting the concurrency strategy on a global level for a persistence unit is good enough. But yeah, with Hibernate's cache annotation, you can fine-tune that a little bit. And let me deactivate this down here real quick. And then you can see that we have the book entity here as well. I also annotated it with add cacheable. So let's take a look at a simple test case. I have one entity manager here and one there. Both load the author entity with ID 1. In a real application, that would probably be, so the one that the part that I highlight here is probably one use case in your backend, and you just call it twice. But here I want to quickly show what happens if you call if you activate caching and call the code twice. So up here we start our test case. And what we do first is we instantiate a new entity manager and transaction, and we try to find the author with ID 1. This is a freshly started test case, which means a totally clean JVM, nothing is in the cache. And you can see here that Hibernate tries to get cache data from the author region, and it missed it. Well, no surprise, as I said, it's empty. So we can see in the log output here that we had a miss on the author region. And we can see down here in the statistics that we had a miss there as well. So Hibernate tracks that in the statistics. Well, because we had a miss, Hibernate now has to go to the database. So Hibernate executes an SQL select statement and reads the author from the database. And because we said that we want to cache the author entity, Hibernate puts that author object into the cache. By default, Hibernate uses a specific region for each entity class. And as a key, it uses the fully qualified class name and the number, the primary key value of that object. All of that can be, right, the region can be adjusted in the configuration. This is Hibernate's default behavior. And when we then run the second, run through the second part of the test case, we see that Hibernate again tries to get data from the same cache region. In this case, Hibernate found it. You can see it here, cache hit. And because of that, there is no SQL statement. You can see down here, no SQL statements and a hit. But as you can also see, even the hit costs a little bit of time, right? So that is significantly faster than the SQL statement, especially considering that in a production environment, the database would run on a separate server, so you have more network overhead and everything. But the put operation, the miss operation, and the hit down here takes some extra time and creates overhead, and that is why we need 9 to 10 read operations for each write operation. Another thing we should quickly talk about is how Hibernate stores the author entity in the cache. You don't need to worry about any concurrency issues with your entity objects. What Hibernate does is Hibernate stores the so-called dehydrated form in the cache. So it uses the fully qualified class name and the ID of the object as the key, and as the value, Hibernate stores all attribute values of that entity object. And when you then get the object from the cache, Hibernate instantiates a new author object, sets all the attribute values it just got from the cache, and then hands you the object. So these are separate objects. A1 and A2 are two separate objects, and you can use them independently. One pitfall here that I want to show before we get to the end is the handling of associations between entities. So here we have the author entity, which I annotated with cacheable, and we have the book entity, which are also annotated with cacheable. So you would expect that if you get an author from the database and then access the books association so that Hibernate initializes it, you would have all the information in the cache, right? So after we've done that, we should be able to do this down here, which is exactly the same, without triggering another database query. Unfortunately, that's not the case. So if we now run the test case, you will see that the author entity was cached, but that we have database queries for the books anyways. So in the first iteration, we see we have 2 JDBC statements and 2 puts. These 2 JDBC statements are the select on the author table and the select on the book table. And well, obviously, author and book were cached in the second level cache. When we now take a look at the second iteration, then we see that we get the author entity from the cache. But then we don't see any log message that tells us that Hibernate tried to get the association from the cache. Hibernate directly went to the database and tried to get all the books associated with that author. And the reason for that is that the association between author and books are not stored on the author table. So they are not part of the author object that Hibernate instantiated up here. They are stored in the author books association table, no, book author association table. If you want to cache that information as well, then you need Hibernate's proprietary cache annotation, and you need to put it on the set of books. So after I've added that annotation, I can run the same test case again, and we will see that in the second iteration, Hibernate will not go to the database. You can see that here, 0 JDBC statements, but 3 hits. So now Hibernate got the author entity from the cache, the association elements from the cache, and the book. And we can print out that Joshua Bloch wrote effective Java without accessing the database at all. Okay, that was a quick introduction to the second level cache. I want to thank you for your attention. If you enjoyed the whole thing, please make sure to visit me on thorbenjanssen.com. You can there also find links to my YouTube channel where I do regular stream on each Friday, and there's a new blog post on each Tuesday and a video on each Thursday. And if you want to really dive deep into Hibernate performance optimization, then check out thorbenjanssen.com/workshop thorben-hpt or just thorbenjanssen.com/workshops. The next one will take place on the 20th of April. And due to COVID, it will, of course, be online and in English. Okay. So yeah, I will be here for a little bit longer. If you have any questions, feel free to post them now in the chat. Yeah. And thanks everyone for attending and all the questions during the talk. It was my pleasure. I hope you enjoyed it. Yeah.
Yes, with several minutes for question.
I mean, we already had a few questions, or quite a lot of questions during the talk, but yeah, if you have any questions, don't have to be directly related to the stuff that I showed during the talk. Also happy to ask other questions about JPA, Hibernate, and similar topics. Yeah, just post them in the chat. Okay, while we are waiting for further questions, what will be the next talk at the JUG in Bordeaux?
Next up, no define encore, oui. Sujet Quarkus. Yes, Quarkus for next month. Quarkus
nice.
and G-Hipster.
Oh, great. Will it be in English or in French?
In French.
Ah. That's a pity. Yeah, I don't speak French. I'm sorry. That one sounds like an interesting one.
Yes. The first release in it's 13 this month.
Mm-hmm. Oh yeah, Julian suggests that I have a month to learn French. Well, that would be a challenge.
The version is not easy.
Well, I speak a few words of French, but I don't think they would really help me for technical talks. So, learning all of that in a month. I had it in school for a while, and it wasn't my favorite topic. Let's say that.
One question.
Yeah, so Clement wrote, just to complete one thing about the distinct keyword, if you put the query hint to true, then there is an impact on the execution on the DB side, right? Yes, it is. Let's take a quick look at that. So it was in the query-specific fetching part. There we had... Where is it? Here. So let's say we remove the query hint. We just do a select distinct A from author A and run the test case. Then the result of the query and of Hibernate's mapping is entirely the same. There's no difference. The important difference is that part here. So now we have a select distinct author ID in our query, and that means that the database needs to sort the query result and make sure that it removes all duplicates. In this case, there are no duplicates that the database could remove because we only have unique combinations of author and book. And if we activate that hint here, then the distinct keyword in the query disappears. Okay, and Christoph asked about my book. You can see the book. You can almost see it. Let me plug my book real quick. So the Hibernate Tips book can get it on my site or at hibernatetips.com. Yeah, it's from 2017, but it's still valid. If you look at Hibernate and at JPA spec in general, the great thing about that is that stuff that you learned today will still be valid in 1, 2, 3, 5 years from now. That's the main benefit of all the Java EE or now Jakarta EE specifications. Backward compatibility is one of the key promises that you get with these specifications. And that means, yes, there are a few features in Hibernate that have been added since I wrote the book, but that doesn't changes anything on the content that is in the book. Yes, sooner or later I will publish an updated version of the book, but I have no date for that yet. And if I look at my schedule for the next several months, I doubt that it will be this year. Yeah. Okay, any further questions?
Okay. Wait 1 minute.
Yeah, if you have any questions after this talk, feel free to reach out to me on Twitter, or maybe join my live stream tomorrow at 3 p.m. CET, and there we can discuss further questions. But yeah, it looks like we answered all the questions so far. Yeah, Julian, thanks for all the questions. Have a nice evening. Maybe see you again soon.
Okay. Do you send the GitHub repo of the sample code?
Can you repeat that?
Oui, do you send a link on the repo sample code?
Yeah.
See, if possible. In chat or Twitter.
There you can find the code.
Yes.
There you can reach me on Twitter, and everything else can be found at
Okay, good.
Yeah, and I will share the link to everything on Twitter directly after this